A giant battle has emerged between mobile phone operators ready to deploy new 5G phone equipment near airports, and aircraft operators landing at those airports. The battle exists because the airlines are afraid that signals from the 5G towers in a particular radio band might interfere with the radar altimeters that planes use to measure how high they are above the ground when visibility is poor. The altimeter is important, and so they are threatening to not fly to certain airports if the 5G is on, or having to abort landings at them if weather changes, and FAA issued rules forbid low-visibility instrument landings that require the altimeters on some aircraft at some airports if the 5G is poor. This dispute was known about some time ago. In the USA, the FCC is the agency which tries to resolve conflict between people using radio signals. It took a variety of steps to avoid any problem, but not enough to satisfy the aviation folks, who made threats of canceling flights. This caused a delay in the rollout, but that delay is over, maybe, and the rubber is meeting the tarmac. To make an analogy, imagine you had a house with no neighbors, and you bought defective Wi-Fi routers which can't work if there's another Wi-Fi nearby. The landlord said it was okay to use the defective ones. Since you had no neighbors, it all worked fine, until somebody moved in next door and set up their perfectly normal and rule-compliant Wi-Fi. Now yours has a small chance of failing at a critical time, like when your emergency monitor needs to call an ambulance. You demand your neighbor turn off their Wi-Fi in case it hurts your broken one. And you knew this was coming many years ago. Since the dawn of radio, we've resolved radio conflicts by partitioning the radio spectrum. Just as broadcast radio and TV are divided into channels or stations which get exclusive use of a particular part of this radio spectrum, so are applications and classes of users. Spectrum is allocated according to the frequency of the old-fashioned carrier wave. When you tune your FM radio to 101.5 MHz, it uses a filter so that it only listens for radio signals close to 101.5. Another station can be at 101.7 MHz, but if people's radios have good filters and transmitting power is managed, your filter will stop the broadcast at 101.7 from interfering with the station you are listening to at 101.5, and so will somebody else's filter. We call a range of frequencies a band, and the size of the range the bandwidth. All old-school radio and TV worked on the same principle, which could be called the analog way of sharing the ether.